So this next lesson will be on solving log equations, but what we want to do is establish a couple things first. First thing is, when we talk about these log equations, we first of all wanted to convert this into an exponential. And so when we do that, we make this b to the t power equal to the inside part n. Now that's the normal way we've done it up to this point, and what I want to emphasize here is that this base here, when we do logarithms, has to be a positive number, and second of all, this number on the inside also has to be a positive number. We can't put in a negative into that number. The reason why is if we had a positive number to a power, we can never have that equal to a negative. So as an example, if I look at this problem, if I make this equal to x and I convert it to an exponential, 5 to the x equals negative 125, notice that I can never put 5 to any power and get a negative. I could make it a fraction, I could also get another number, but I can't make it a negative. So I can't do this. I can't have a negative as part of the domain that I put into a logarithm problem. That'll help us when we're doing some of these other problems. So the next thing I want to do is set up for us the type of problem I want us to do. For instance, if we want to take and do a problem that is log base 18 of 4x equal to log base 18 of 2x plus 5. We want to do this type of problem now where we solve a log equation where there's a log on both sides. We're not going to set this up as an exponential because this would mean we take 18 to up this power and this would have a log in the power. So we're not going to set it up that way. Instead, we're going to use a new rule. We've got a rule that allows us to do this problem that says if you've got two logs equal to each other and they have the same base, so if I've got log base b of x equal to log base b of y, that means that if they have the same base, we can just set the inside parts equal to each other, that x equals y. This is the new rule that we're going to use when you've got logs on both sides and they've got the same base. Okay, that's what we'll solve. So let's go ahead and solve this one. Since it's log base 18 of 4x equal to 2x, log base 18 of 2x plus 5, we can take and set the two inside parts equal to each other. 4x we can set equal to 2x plus 5. Now we can solve that equation by taking and subtracting 2x from both sides. So we can get 2x equal to 5, and then divide by 2 on both sides and get x equal to 5 halves. So there's our solution, and when we put that back in, if you put 5 halves back in here and 5 halves back in there, it doesn't give you a negative on the inside. That's your check that you've got to do with these log equations, is make sure that when you substitute it back in, you don't get a negative. So now, once we've solved that one, let me set up another problem and let's have you try it. Okay, so this next problem, we're going to use the same rule for it. So to do this one, I'm going to have us try log, let's try base 2 of x squared minus 5 equals log base 2, and on the other side here, we're going to have it be of 4x. Now why don't you pause the video and try this one. See if you can do this and make sure you check your answers. Let's go ahead now and do it together. Let's take this, and since we've got log base 2 on both sides, what we're going to do is set the inside parts equal to each other. So we get x squared minus 5 equal to 4x. Now, this is a quadratic, and how we've solved quadratics in the past is that we get 0 on one side first, and then we solve it. So I'm going to go ahead and take and subtract 4x from both sides, put it in order the way that we usually do with quadratics. Now I'm going to factor this, and so what I'm looking for when I factor it is I'm looking for two numbers that multiply together to give me this -5, and then add together to give me that -4. Well, those two numbers are -5 and +1. And now I use the zero product property. I set x minus 5 equal to 0, and then x plus 1 equal to 0. Solve each of these by adding 5 to both sides. And here I'm going to subtract 1 from both sides. And notice I now get two answers. Now there's a possibility that two answers could work, but wait a minute, we got to check them. If we put 5 back in here, 5 squared is 25 minus 5 is 20. That's a positive number. That's okay. 4 times 5 is equal to 20. That's okay also. Those two are equal, 5. So 5 is an answer here. But let's check -1. -1, when we put it in, -1 squared is 1, minus 5 is a -4. You can't have the log of a negative, like we just talked about. You can't have the inside of the logarithm be a negative. So this negative number here, sometimes negatives will work, just so you know, but in this case, putting in -1 into both of these sides doesn't work, so we get rid of that solution. Our answer is only x equals 5. So in summary, first of all, what we need to do is when we have a log with the same base on both sides, we need to set the inside parts of them equal and solve. Once we do, though, you need to take your answers and make sure when you look back at the original that either of those answers, or whichever answer you get, doesn't give you a log of a negative, because that's not allowed. And otherwise, you get your answer.